Welcome back for your very final note guides in pre-calculus on polar coordinates. This is PN42 Part D. Part A, I showed you how to graph points in the polar coordinate system. Part B, we actually graphed equations in the polar coordinate system. Part C, I showed you how to convert from polar coordinates to rectangular as far as points go. Now, we haven't done anything bigger than that, but we are able to switch points from both polar coordinates to rectangular. Now, on the top of this note guide, notice, well, first of all, make sure you have your title there, but I put the big general equations down where we have x equals r cosine theta, y equals r sine theta, r squared equals x squared plus y squared, and tan of theta is equal to y over x. These are things we know, we love, we've worked with them, and so those tools are really, really important for what we're going to do today, which is not just taking a point and converting it over to rectangular or polar form, but actually taking equations and switching them backward and forward. So number one, this is where we begin. It says write the polar equation r equals -3 in polar form. The trick to this one, well, first of all, I do want to say, you notice I wrote circle over here because, well, you do know it's a circle with a radius of 3 and a center of 0, 0, so you could really just seriously instantly write this equation. But what I'm going to do is show you an algebraic method because we want to make sure you have more than one tool in your tool belt kind of thing. So the trick here is to square both sides of equation, okay? So if I square both sides, I'm going to just do this because I don't have the space there. We're going to end up with x squared equals 9. And now, here's where the magic happens, and I'm going to just remind you that we know that r squared equals x squared plus y squared, so what we can do to switch it over to rectangular form, which is always in x's and y's, we want to replace r squared with x squared plus y squared, coming right from the Pythagorean theorem, equals, oops, I could be a little bit more consistent here. What color was I? Was I blue? Equals 9. So we literally replaced r squared with x squared plus y squared. Where is that coming from? Right here, ladies and gents, right there. Okay, and now, you know what, there's no simplification or anything. That is it, because we know that x squared plus y squared equals 9 is the general form of the equation of a circle. That gives us with a radius of 3 and the center of 0, 0. Yay, not too complicated. I get that. And would you have needed to do all of this to get to that equation? No. If you recognize that that's a circle with a radius 3, you could have wrote the equation in rectangular form without any further ado. But sometimes it's a little bit more complicated. Oops. Like this one here. It says write the rectangular equation, I'm looking here, of x squared plus y minus, x squared plus the quantity y minus 1 squared equals 1. And we want to write this in polar form. Now, before we switch it to rectangular, now we're switching it over to polar. The trick with these is that you're going to need to use those top equations somewhere in there. It almost reminds me a lot of trig identities in that respect. And the first thing I notice, I do have an x squared. I'd really like a y squared, and I do have that, but I need to expand this out, this equation. So I'm going to have, and I'm going to write this, I'm going to make this a little bit bigger. So I have x squared plus, and I'm going to write y minus 1 times y minus 1. Because that's quantity squared, equals 1. And I'm going to extended distribution, or if you like to call it FOIL. I have y times y, which is y squared, negative 1y, which gives me negative 2y, plus 1 equals 1. And from here, I do want to make sure you see that right here, look at what we have. We have x squared plus y squared. And why is that important? Because, oops, I'm going to leave it in this really obnoxious green, because then I know that if I'm switching over to polar form, which is all in r's and thetas, is that I know that x squared plus y squared actually is x squared plus y squared is actually r squared. Or vice versa, right? Okay, now I'm going to switch back to the blue. Minus 2y, and by the way, I can subtract 1 from both sides, and that makes that go away, so I have minus 2y equals 0. So I am now down to 1y, or actually I have 2y's if you want to get technical, and negative 2y's, really, if you want to get super technical. But I do need to get rid of that y, and I'm going to remind you, I'm going to switch this over here, that I have that y is equal to, right here, y is equal to r sine theta. So I'm going to go back down to where I'm working and replace that y. Should I go back to that really? No, I'll just leave it at that. I'm going to have r squared minus 2, but instead of y now, I'm going to replace it with r sine theta. Now I don't have to switch colors anymore. Equals 0. Okay, so we substituted in for y the r sine theta. Now, what is super, super cool is that we don't have any more y's or x's, but now we need to simplify it and make it a little, look a little bit better, right? So I'm going to look at both of these and notice that I do have a common r, so I'm going to pull that r out, that GCF, and I'll have r minus 2 sine theta left over equals 0. So I just factored using the greatest common factor. If I were to go one step further, I know that this means that I have r equals 0, and I have r minus 2 sine theta equals 0. So you do need to get it so it's set equal to r. The r equals 0 is a negligible one, but looking at this one right here, I'm going to bring it up here, I end up with r equals 2 sine theta, and that is exactly what I want. And if you want to say you have a circle, and I actually find it easier to look at the original, the rectangular form, because we're much, much more comfortable with that. We do know that it has a radius of 1, and again, going back to the original here, it not only has a radius of 1 because of this value right here, square root of 1 is 1, but we also have a center. There's no shift here, there's a shift here, so our center is at 0, 1. And you could graph it and life is good. Now, you may be asking yourself, where is this r equals 0 coming from? If you actually think about it, and I'm just going to plot this point really, or graph this really quick. 0, 1 is right here. There's our center, and here is, oh geez, is our circle. R equals 0 is right here, this point and this spot. So, you know, it's, again, this isn't the answer right there, but I do want to let you know that it's not, I mean, there's a reason that it's there, but really the equation that we're after is this one right here. So r equals 2 sine theta will give you a nice graph that will look just like that. Okay, so now if you look at that r equals 2 sine theta, and then example number 3, notice that we have some similarity there because it says write the polar equation r equals 4 cosine theta into rectangular form. And I need to kind of move this here so I can see it. So we are going to have some similarities here as far as that whole thing goes. And the trick, now here's the thing, the trick to this one, because you do need that r squared, you may think to yourself, I want to square both sides. But if you square both sides like you did in example number 1, which is different, if you look at number 1, that's quite a bit different than example number 3. The difference is you'll end up with theta squared, and that's not what you want at all. So the trick to this one is that you're going to want to multiply, and I'll put the note over here. Here's your trick. No, sorry. The trick is to multiply r, and that was supposed to be quotes, but you're not going to see that. Multiply r on both sides of equation. So instead of squaring in this situation, you want to just multiply by r. So multiply this and multiply this by r. And look what happens. When you take r times r, you end up with r squared equals 4r cosine theta. Now, of course, we know that r squared is going to just be x squared plus y squared from above. So I'm just replacing that r squared with x squared plus y squared. Notice it does feel a lot like identities. Equals, by the way, that was an equals right there, equals 4, do you recognize this right here? This right here, r cosine theta, look at the top of your sheet, and you'll know, or hopefully you can see that that would be x. So those are just kind of replacing things so that now we are out of the r's and thetas and only have x and y's. Now we do want to get this into a form that makes some sort of sense, because obviously we have a circle here because we have x squared plus y squared, so we have an x squared and y squared. But I have this 4x also, which is really bizarre. So I'm going to have x squared, I'm going to move that 4x over, so it's going to be minus 4x plus, and I'm going to just leave a blank here for a minute, and then I have plus y squared equals 0. So I do have a 0 over on the right side now, and I have all my other stuff on the left. And I'm leaving that space because I want to show you right now, and I'm going to be teaching this very, very formally next chapter, but I want to show you how to complete the square. And I know some of you may have seen this already, complete the square. But some of you may not have, and I just want to kind of step it up a little bit and make sure that you guys have some experience with this. And what we're doing is ultimately what we're doing next is trying to write it like, if you look at example number 4, we want to write it like that, where you have like x minus or plus a number, quantity squared, or like this right here. Now, what we do with this so that it becomes factorable is we literally complete the square. And what you do is you take this middle term, which if you just kind of focus just right on this spot right here, we're trying to figure out what to add to this in order to be able to make it factorable. And the way you complete the square is you take your middle term right here, I'm going to bring it over here, divide by 2 and square it. This is a pattern that happens over and over again. You take whatever that middle term is, divide it in half, and square it. And if we do that, we have negative 2 squared, which is 4. So I'm going to add 4 to this side. And of course, if we add 4 there, we have to add 4 to the other side of the equation, otherwise it's not balanced. Now, what does that do? Why do we do that? Well, if you factor x squared minus 4x plus 4, using your wonderful factoring techniques, you will realize that you end up with x minus 2 and x minus 2. So use whatever method, whether it's Kruger's method, Murphy's method, whatever method, Hansen's method, factor that trinomial, you'll end up with x minus 2 times x minus 2 plus y squared equals 4. And this, because those factors are the same, we can write it as x minus 2 quantity squared plus y squared equals 4. So completing the square, that's the only new thing here as far as something a little bit kind of quirky. We do it a lot in the next unit, so I thought I'd kind of bring it in a little bit here so that it's not completely shocking later on. Looking at this, of course, we know that we have a circle. I'm going to write that over here. So this, by the way, final answer, right here. And what do we have? We have a circle, obviously. We have a radius of, well, we have a 4 over on the right-hand side. Take the square root of that, so the radius is 2. And we have a center that is 2, 0. And that's super cool. So that is the way you switch from polar coordinate over to rectangular coordinate for an equation like r equals 4 cosine theta. One last one here. It's write the rectangular equation of that circle, and I assume it means write it in polar coordinate form, and it's missing. So write this in as a polar. So in polar, that's really funny. It's missing. Okay, anyway. Okay, so let me kind of move this up and kind of get us all nice and ready to go here. And I'm going to just erase a little bit here so that that it doesn't kind of get us confused. Okay, here we go. So we know instantly this is a circle, the center is at 3, 2, our radius is the square root of 13, and you know, if we want to just do that right away and say that off to the side, so we have a circle, the radius is square root of 13 because that's not a perfect square by any means, and where am I getting that from? Right there. And the center is at 3, 2. So if it's in this form of a rectangular equation, it's super easy to get that information. But we want to get it into a polar equation. And so what we want to do is we want to first expand this all out. So we're going to go x minus 3, that's a minus, times, ooh crap, hold on, x minus 3 plus y minus 2 times y minus 2, and we have 13 over here on the other side of the equation. Okay, and so when we FOIL these out, expand it out, we end up with x squared, I have to be careful, make sure I get my numbers right, minus 6x plus 9 plus y squared minus 4y, that was weird, it glitched on me, minus 4y plus 4 equals 13. Okay. Now you can, again, think kind of trig identities here, put things kind of together that you would want to put together. I want to put the x squared with the y squared because that can be substituted in. We can put r in there. And then we have minus 6, I'm going to have that x, minus the 4y, and then my constants I'm going to move to the other side. So notice that if I subtract 9 from both sides, so if I subtract this value from both sides and this value from both sides, you end up with a 0 over on the right hand side, which is lovely. Okay, so let's start moving things or manipulating things. So we know this is now r squared. We know that we can replace x with r cosine theta. And we know we can.
Ladies and gentlemen, the grand prize winner of the 2 Little Wing ticket limo ride at 93.1 flag is Sammy Nelson. Please come to the main office to collect your prize. Sammy Nelson, you're the winner of 2 Little Wing tickets and a limo ride. Meet me in the main office. Thank you.
Congratulations, Sammy, although I don't know if the lady realizes she interrupted my video. But anyway, okay, so what I'm doing now is I'm pulling out the common factor, the GCF of r. So instead of r squared, it's r minus 6 cosine theta minus 4 sine theta equals 0. So we're just pulling that common factor out. Why do we do that? Well, because then we get that r equals 0 again, which again is negligible. We don't need to worry about it. And we end up with this r minus 6 cosine theta, I'm almost done, minus 4 sine theta equals 0. So you do want to solve for r, just like above. So we're just going to move everything over to the other side. We have 6 cosine theta plus 4 sine theta. And you may say, can I, Ms. Bakken, pull out the 2 in this right side? Yeah, if you really want to. But you know, at this point, I'm just happy you're able to expand out, use a lot of algebra here, substitute in things that we know. And I think I'm going to finish just because they're going to keep interrupting me otherwise. So homework, I just want to say this. I don't like 36. I do like 37. Instead of 36, I want you to do number 38, 42, and you know what? Just to be very, very kind to you, get rid of 54. And these right here, let's just do the odds. Let's just do the odds, okay? So we're going to be doing 37, 38, 42, and then really 43 through technically 49 odds. If you have any questions on how to convert rectangular to polar or polar to rectangular, I will answer those next time we see each other.